Hello there, and welcome to Science for Sleep. I'm really glad you're here. Maybe you've just curled under a blanket, the light's soft and low, maybe the night is quiet around you, and your thoughts are just beginning to slow down. Wherever you are, city, mountain cabin, a little corner of the world only you know, this space is for you. A place where science moves slowly, where the big questions can unfold in their own time, like a window cracking open to the dark, starlit sky. And tonight, the question is this: what if the universe remembers everything? Not in the way we remember birthdays or names or the smell of rain in summer, but in a way that's quieter, more complete. What if every movement, every flicker, every small decision, every event was not just something that happened and then disappeared, but something that left a mark, something that stayed in the fabric of things even after we forgot? You might wonder why that matters. It's just a thought, right? But sometimes one quiet thought can pull you into a deeper kind of stillness, a calm that comes not from knowing everything, but from realizing how much is still unfolding. You don't have to race to the end. You can lie back and let the questions carry you. What time is it where you are? Late? Early? Does it even matter right now? I like to think of people listening from all over. Little lights scattered across the night, some wrapped in silence, others with city sounds outside their windows. Maybe you're in a familiar place, or maybe you're listening from somewhere new. Either way, if you're finding this peaceful, I'd be so glad if you tapped the like button softly, or subscribed so we can wander through more sleepy science together. Now, close your eyes for a moment if that feels good, or just soften your gaze. Take a slow breath, then another. Let yourself sink just a little deeper into wherever you are. The bed beneath you, the chair, the floor, it's all holding you right now. And above you, if we peeled the roof off the sky, there'd be stars, hundreds, thousands, each one a tiny glowing record, a message not from now, but from long ago. That's where we begin. You've probably heard before that when you look at a star, you're seeing it as it was in the past. Light takes time to travel. A star that's 100 light years away sent that beam of light 100 years ago, which means you're not looking at how it is, you're looking at how it was. And in that small, simple fact, there's something incredible. The sky isn't just a view, it's a record. Every star, every faint shimmer, every cold beam of light is an old photograph. The universe isn't just expanding, it's also remembering. This light, the stuff that makes up starlight, doesn't just flicker and disappear. It travels, it leaves, it moves in a straight line unless something bends it, and it keeps going. Some of it will go on for billions of years, past planets, past dust, past whole galaxies, uninterrupted, undisturbed, carrying its message with it, a picture of the moment it was created, a silent imprint of what once was. And here's the quiet truth: your eyes are part of that journey. When that light reaches you, when it finally touches the surface of your eye, or the sensor in a telescope or a mirror angled just right, it ends its long flight. And for a moment, that piece of history is seen. It doesn't speak, it doesn't explain, but it's there. It's easy to forget this in daily life. We flip on lamps, scroll past images, live in fast cycles of information and distraction. But outside all of that, above all of that, the universe keeps sending its memories toward us. Not in words, not in symbols, just in light. That alone is strange enough. But the more you think about it, the stranger it becomes. Because if light carries memories across space, it means space itself is full of memory. Full of old signals. Full of data that hasn't been erased. It's not a stretch of emptiness. It's a slow, patient archive. And it doesn't stop with stars. Light isn't the only thing that remembers. Think about gravity for a moment. It feels like something constant and dull. The pull that keeps you in your seat. The thing that makes things fall. But what is gravity really if not a form of memory? When a planet pulls on a moon, when a star tugs at a comet, When a black hole bends the path of something that comes near, it's because of where mass is, because of what has happened. Gravity is not a force that just acts. It's a consequence, a result. It's the memory of mass pressed into space. It curves space itself. It shapes how things move, not because it pushes, but because the space around mass is no longer flat. It's bent. It's shaped by what's there and what's been there. In that way, even movement is a form of memory. The path a planet takes around a star isn't random. It's predictable, calculable, because it follows a shape created by gravity, and gravity follows mass. The dance of planets and moons and satellites and dust particles is not a freestyle. It's a choreography based on memory, based on location, based on weight. So space isn't just something things move through. It's something that remembers where things are, where they've been. It shapes the future by holding on to the past. Now zoom in closer. Imagine a rock sitting on the ground. You pick it up and move it. Even that tiny act changes the space around you. The gravity field changes. A microscopic ripple, almost impossible to measure, but real. You have altered the layout. You've changed the position of mass, and space responded. Maybe not with a roar, maybe not with a visible wave, but with a shift. And that shift never goes away. It may get smaller, it may spread thin, but it's there. If that feels far away, think about light switches. When you flip one, a current flows. It moves through the wires, turns a bulb on. But in the process, you've changed the electromagnetic field in the room. Again, not by much, but enough. Enough that, with the right sensors, someone could tell. They could know that something happened, that an action was taken, and even if you flip the light off again, the trace remains. Every interaction leaves something behind, every motion, every spark, every heartbeat. Now, of course, memory in humans doesn't work like that. We forget things all the time, names, faces, whole conversations. Our brains are built to lose information, to make space, to let go. But the universe, it doesn't forget in the same way. It may not remember the way you do, but it holds everything. Every photon, every collision, every turn of a molecule, not in a scrapbook, not in a book at all, just as changes, as shifts in field lines, as scars in space. And that brings us to something even stranger. If the universe remembers everything, where does it keep that memory? Is it in the light? We've said yes. Is it in gravity? Also yes. But maybe it's deeper than that. Maybe the memory is in the fabric itself, in space-time, in the quantum fields that ripple beneath reality. There's a theory, still debated but fascinating, that the universe is like a hologram, not in the sci-fi sense, not made of light beams or virtual projections, but in terms of how it stores information. A hologram is a two-dimensional surface that stores three-dimensional data. And some physicists have proposed that the universe too might work this way. That all the information inside a region, every particle, every interaction, could actually be encoded on the surface around it. It sounds impossible, but the math supports it. In some black hole models, this is exactly how information is preserved, because one of the puzzles of black holes is this. What happens to the information that falls in? If you throw a book into a black hole, does the story disappear forever? That breaks the rules of physics. So instead, the theory says the information gets smeared across the edge, the event horizon, stored there like a cosmic hard drive, imperceptible, but complete. And if black holes work that way, maybe the universe does too. Maybe everything that happens in a space is also reflected in the edges around it. Maybe your very presence here, listening now, adds to the data written into the cosmos. A soft imprint, a line of code. Not noise, but signal. It's not proof, not yet, but it's a possibility. And even without the hologram, there's something to be said for the way the universe holds on to change. Think of the fossil record. Rocks that once flowed like lava, now hardened into shapes that hold the trace of a leaf, or ice cores, drilled deep into glaciers, each layer holding air from thousands of years ago. Each one a breath caught in time. Trees grow rings, canyons remember water. The Earth itself is a library. You don't need magic to find memory. You just need to look carefully, to listen, and somewhere, far above all that, the light keeps coming. Starlight galaxy light, bursts from quasars and faint radio whispers, all still travelling, all still holding the shape of what once was. If the stars are old messages, if the light above is memory travelling through space, then maybe it's not too far a question to ask whether the sky itself remembers you. Not just in a figurative sense, not as metaphor or poetry, but as a real, physical question. When you look up, when you walk under the open sky, does anything notice? Does anything respond, even quietly? Could the presence of a single person, one breath, one heartbeat, change the shape of the universe, even a little? Most of us have walked under a night sky at some point in our lives and felt something. Not fear exactly, not even awe, though that's part of it. Something closer to recognition, as if the silence above isn't empty, as if it's full of listening. Maybe you've had that feeling too. Alone outside, surrounded by cold air and soft dark, and it seems like the stars aren't just distant suns, but a kind of presence. Familiar, steady, watching. And in a way, they are. When you stand under the stars, you're not just seeing them, you're participating in a shared history. That starlight isn't simply arriving at your eyes, it's completing a journey. A journey it began long before you were born. A journey through dust and void and bent space, just to reach the exact point where you happen to be standing. That matters. It means you were part of the equation. Your presence mattered to the path of the light. Without you there to receive it, that journey would have continued, but it ended with you. Quietly. Completely. That's one kind of memory. A path that completes itself in contact, a story that gets its ending. But there's another layer, a deeper one. Because the moment you stand there, outside, still, looking up, you're doing more than receiving light. You're also emitting it. Not in the same way a star does, not in beams or pulses, but in infrared, in body heat, in electromagnetic waves. Your body glows, softly, constantly, and that glow travels. You're not just looking at the universe, you're shining into it. Even now, wherever you are, wrapped in blankets, still beneath the weight of sleep or thought, you're sending out a signature, a real, physical pattern of warmth and radiation that moves outward from your body, through walls, through air, into the open. It spreads and diffuses and dims, yes, but it doesn't vanish. If someone had the right instruments and enough sensitivity, they could measure the change you made to your room, your street, your little corner of Earth. They could know that you were there, and if that's true on Earth, it's also true beyond. Every action you take, the way you shift in your bed, the light you turn off, the electronic signals your phone quietly emits, all of it contributes to the electromagnetic fingerprint of Earth. A fingerprint that spreads into space. It moves outward, sphere after expanding sphere, like ripples from a pebble dropped in water. Some of the earliest radio broadcasts ever sent are still travelling. Old music, static, conversations, all moving outward at the speed of light. They're faint now, scattered and stretched. But they exist. The sky holds those signals, or at least it receives them. That patch of sky above you, it isn't blank, it's full of signals. Human ones. Yours, even. If you've ever made a phone call, if you've ever used Wi-Fi or sent a message that travelled by satellite, some trace of that is moving through the sky right now. Not as a memory in the usual sense, not as a diary entry or a saved photo, but as data, as energy. The universe doesn't organise it, doesn't file it away. but it doesn't erase it either. The sky receives everything. Now, most of it fades, most of it mixes and thins out and becomes background noise, but that doesn't mean it never happened. And the fact that it happened, the fact that you happened, means that for one moment, the universe changed shape around you. Maybe only a little, maybe so slightly that the difference is invisible, but still there's no undoing it. Your body, your motion, your signal left an imprint on the field. That's the strange thing about physical memory. It doesn't require intention. You don't have to mean something for it to be remembered. You just have to be. You just have to exist in space and time, and the consequences of your existence ripple outward. So when you lie under the sky, when you breathe and stare upward and feel something stir, it's not just imagination. There's a feedback loop happening. You're receiving the memory of stars, and they're receiving something of you. Not thought, not emotion, but presence. And if you wonder whether that really counts, whether something without a mind can remember, you're not alone. It's a big question. But it's one that physics actually takes seriously. Because memory as a concept isn't limited to minds. In physics, memory can be encoded in the state of a system, in the position of particles, in field lines. Even in a void, even in a vacuum, there are structures, fields that stretch across the emptiness. Higgs fields, electromagnetic fields, gravitational curvature. They are sensitive, they respond, and when something passes through them, they shift. In that shift, the memory is written. There's a term for one version of this, the gravitational memory effect. It refers to a specific kind of change that happens when a gravitational wave passes through an area. Even after the wave is gone, even after the shaking is finished, the particles it passed through don't return to exactly where they were. They stay just a little displaced, as if space itself remembers being stretched. That's not science fiction, that's general relativity. So yes, the sky remembers. It may not catalogue, it may not interpret, but it holds on to the changes you make, the warmth of your body, the signals you send, the particles you move, the atoms you displace when you breathe. You leave a trail even in stillness. There's also another kind of memory, one that gets a little stranger the deeper you look. It comes from quantum physics. It's the idea that particles don't just follow one path, but every possible path. That what we see is just one outcome of a much larger range of possibilities. And more importantly, that those unchosen paths don't just vanish, they linger, they interfere, they contribute to what is. In some interpretations, this is a kind of shadow memory, the memory of what could have happened, the memory of options not taken. You move your hand, you blink, you shift your weight. Each of those decisions could have gone differently, and in a quantum sense, the wave function that describes you includes all of those paths, until something measures it, until reality makes a choice. And even then, the full equation never goes away. It continues to evolve. It carries the history of what was possible, along with what actually happened. It's hard to think of yourself that way, as a cloud of probabilities, as something that includes all the things you might have done. But that's part of the physics, part of the memory. The full system still holds the shape of what you could have been. So the sky doesn't just hold your signal, it might also hold your pattern, not in the clouds, not in a poetic way, but in the underlying fields of quantum reality. That's a kind of memory too. All of this might seem remote, like something only physicists need to worry about. But if you lie still for long enough, and if you let your thoughts move slowly through it, it changes something. The way you feel your place in space, the way you understand silence, the way you look up. Because this is the truth. Even if no one else sees you, even if you say nothing, even if your day passed in complete quiet, the universe knows you are here. Not with mind, not with eyes, but with record, with response. There are molecules in the air that have brushed against your skin and will never be the same. There are photons that bounced off your hand and are now travelling outward. There are electrons that shifted slightly because of your warmth. The sky and everything beyond it felt that. And it won't forget. It may not assign meaning, but it will keep the change. And so the question isn't just whether the sky remembers you, it's whether anything is ever truly forgotten. Maybe the stars aren't looking down, but they are shining out, and the light you send back, small, silent, soft, adds to the pattern. It always has. There's a kind of comfort in knowing that light doesn't forget where it came from. It just keeps moving forward. Silent, straight, steady. You don't have to ask it what it's seen. You just have to watch it arrive. Because when it does, it's not bringing the present with it. It's carrying the past. Every beam of light you've ever seen, every sunset, every reflection, every pinprick of starlight overhead started somewhere else. And a long time ago. It didn't just appear for your eyes. It began in a place you'll likely never visit, at a moment you'll never experience directly. Light is a traveller, a courier. It crosses vast distances, not because it's fast, though it is, but because it's patient, and it never stops until something catches it. You could look at the night sky right now and find a star a few hundred light years away. That means the light reaching you tonight left that star before your grandparents were born, before the cities around you looked anything like they do now, before electricity, before radios, before cameras. That beam of light has been travelling your entire life, and many lives before yours, not because it was trying to, just because that's what light does. It keeps going until it can't. And when it reaches you, your eye, your window, the surface of your skin, it doesn't carry a message in words. It carries shape, pattern, energy, a kind of fingerprint of the moment it was made. The light you see from a star is what it looked like then, not now. You're not watching its current state. You're watching its memory. That's true of everything you see, even the people around you. The light bouncing off their faces doesn't reach your eyes instantly. It takes time. Tiny fractions of a second, sure, but real time. When you see someone smile, you're seeing it after it already happened. It's only by convention and the limits of our senses that we call it now. The light left their face, crossed the space between you, and only then landed on your retina. For something far away, the delay grows. A moonbeam is about a second and a half late. Sunlight takes just over 8 minutes to arrive. A signal from the edge of our solar system takes hours. From the next star, over 4 years. The farther the source, the deeper into the past you're seeing. Light is not just illumination, it's record-keeping. And unlike us, light doesn't get tired. It doesn't forget where it's been. It doesn't fade in the middle. It keeps its message intact across distances that stretch the limits of time itself. Even when it's scattered by dust or stretched by expanding space, it holds on. Sometimes redder, sometimes weaker, but always carrying the shape of its beginning. That's how we know what the early universe looked like. Not because anyone saw it firsthand, but because the light from that time is still travelling, still arriving. The cosmic microwave background, the oldest light we can detect, has been moving through space for over 13 billion years. That means the moment it comes through your radio telescope, you're touching the afterglow of creation itself. A real signal made at a real time, still echoing across the sky. And it's not just old, it's precise. It contains the structure of what space was like back then. Its tiny variations in temperature and wavelength tell us how matter clumped, how galaxies started to form, how the early universe behaved. Light doesn't embellish, it doesn't reinterpret, it just delivers what happened, exactly as it was. It's the most honest storyteller we have, which makes it strange to realise how easy it is to ignore. Most of the light around you doesn't even reach your conscious awareness. It bounces, scatters, reflects, absorbs. Some of it heats you, some helps you see, some just fades into the noise. But it's all there, moving through space, connecting past and present. You can turn off a light bulb, but the photons it released before that moment are still going, outward, past the walls, past the sky, on their way to whatever they'll hit next. They don't care if you're watching. And maybe that's what makes them so dependable, because whether you're noticing or not, light is working, carrying stories, carrying structure, not because it's trying, just because that's how it behaves. A photon, once created, has no way to stop. It doesn't slow down, it doesn't decay in flight, it has no rest frame to light time doesn't pass. From its perspective, the moment it's born and the moment it's absorbed are the same. No waiting, no journey, just a jump from origin to destination. But to us, from where we stand inside time, that journey is long, and because of that, every photon becomes a kind of memory, a way of knowing not just what something is but what it was. A photograph isn't just an image, it's a record of light frozen in place. When you look at a photo from 10 years ago, what you're really seeing is the light that bounced off that moment, light that hit the camera sensor and stopped there, a message from the past stilled. In that sense, every camera is a trap, a way of catching time and holding it still. But most light doesn't get caught. It escapes, it spreads, which means there's more history in space right now than there is in any library on Earth. There are signals moving through the void, untouched for billions of years, beams from stars that exploded before life began, echoes of quasars that burned long before our sun was born, information in the form of light still in transit. And some of that light passes through you. You don't feel it. It doesn't announce itself, but it's there, passing through the layers of your skin, refracting, scattering, bending around bone, sometimes absorbed, sometimes kept, sometimes reflected outward again. You're not just a receiver of light, you're part of its journey, a point along its path, a new surface for it to touch. In that way, you become part of the story it tells. There's something humbling in that. You're not separate from the archive, you're inside it. Every second, the light touching your body is recording where you are, not in words, not in thoughts, just in the silent interaction between energy and matter. And when that light leaves, if it reflects, if it refracts, it carries with it a trace of you. Not your name, not your voice, but your position, your presence, your shape. Even now, sitting or lying still, you are shaping the light around you. You're scattering photons. You're giving the universe one more piece of data about what's here, right now. And you don't get to erase that. Not fully. You can turn off a light. You can sit in the dark. But the photons already created are still moving, and the ones bouncing off your skin are still being changed. You are still part of the signal. That's not superstition. That's just physics. So when you think of light as something gentle, something quiet, that's fine. It often is. But it's also relentless. It's thorough. It doesn't ask permission, and it doesn't forget. The next time you look at the stars, remember this. You're not just seeing them. You're also being seen in the only way the universe sees. Through light, through energy, through interaction. Your body is visible, even to the cold silence of space, and the light you reflect may one day reach someone else's eyes. Maybe not tomorrow, maybe not in this galaxy, but somewhere that light is going, carrying your moment with it. And so we begin to see that light isn't just information, it's connection. It links places, moments, people. It creates a thread between what was and what is, between a star's surface and your eyes, between your movement and the fabric of space around you. That's where we're going next. If light is memory, then gravity might be something even deeper. Not just what holds you here, not just what shapes orbits or makes things fall, but something that holds on, that preserves, that remembers in its own way, not through travel, but through shape. You've probably thought of gravity as something ordinary, background, familiar. You don't need to understand it to know it's there. You drop something and it falls. You sit still and you stay grounded. You don't float off your bed in the middle of the night, even though nothing seems to be holding you. Gravity does that, quietly, without explanation. But for something so constant, it's strange how rarely we question what it really is. We think of it as a pull, a downward tug, a force that keeps everything in place. But what if that's only half the story? What if gravity isn't just a pull, but a record? Not something that simply acts, but something that remembers. The way gravity works isn't just about weight, it's about shape. According to general relativity, gravity isn't a force pulling objects toward each other. It's the result of space itself being curved by mass. A massive object like Earth presses into the fabric of space, and that curve is what we feel as gravity. You're not being pulled down, you're following the slope of the space you're in. Now here's where it gets interesting. That curve doesn't go away when something leaves. If a massive object moves through space, the shape of that space is changed. Subtly but permanently. It's not like a mattress that springs back to normal, it's more like clay that holds a fingerprint. The more massive something is, the deeper the curve. And those curves can stretch across vast distances. The moon orbits Earth not because of a line connecting them, but because Earth has reshaped the space around it in a way the moon can't ignore. In that way, gravity is a kind of memory. The presence of mass alters the structure of space, and that structure dictates how everything else moves. A planet remembers the star it orbits, not consciously, but physically. The motion of the planet is the result of that memory. The same is true of comets, moons, satellites, dust. None of them have choices. They move the way they do because of the space they're in, and that space is shaped by what has been there. Even when things move on, the influence remains. That's what makes gravitational memory more than just a poetic phrase. There's a literal effect in relativity theory called the memory effect. When a gravitational wave, a ripple caused by the movement of massive objects, passes through a region, it leaves a permanent change. It doesn't just push and let go. It alters the positions of particles slightly, forever. Space doesn't return to exactly the way it was. It remembers. That ripple, even if it's faint, carries the shape of what caused it. Two black holes merging, a neutron star spinning apart. The source is long gone, but the effect moves outward. And after the wave passes, there's a mark. A small shift in the structure of space. That's gravitational memory. And you don't need a telescope to believe it. The equations support it. The instruments have detected it. It's real. That might seem abstract until you realize it applies here too, on Earth, in your body, right now. Your mass, however small in the cosmic sense, still presses into space, still curves it. The shape might be tiny. It might only reach a few centimeters before fading into the curvature created by the Earth. But it's there. You bend space by existing. You're not just responding to gravity, you're participating in it. Every time you move, the curve moves with you. The world reshapes itself around your weight, your presence, your direction. It's not dramatic. It's not something anyone will notice. But in principle, it's measurable. If something passed very close to you, a beam of light, a stream of particles, it would bend just slightly because of your mass, because of how you curve space, because of the memory your body writes into the structure of things. And it works in reverse too. The Earth curves space around you. So does the sun. So does the galaxy. When you feel weight, what you're really feeling is the slope of the space beneath you. You're trying to move in a straight line, and the curvature is redirecting you downward. Not by pushing, not by pulling, just by reshaping what straight means. That slope is a product of history, of mass accumulating, of stars forming, of matter collapsing over billions of years. Your weight is not just the result of the planet, it's the result of the entire history of matter that led to the planet being here. Every atom in the Earth is part of that chain. Every one of them has shaped the geometry you're lying in now. That's why gravity doesn't let go. Because space keeps its shape. It doesn't bounce back. It adapts slowly. but it doesn't forget. Even if something explodes, even if it moves away at nearly the speed of light, the memory of where it was, the shape it made, continues. The gravitational influence stretches outward, rippling at light speed, never quite undoing itself. A dying star collapses, its light stops, but the gravity remains. For a while, it behaves as if the mass is still there. Then, gradually, the new shape takes over. The change spreads, but it never erases the fact that something happened. It only updates the record. So when you ask if the universe remembers you, gravity answers yes. Not with thoughts, not with intention, but with shape. If you dropped a pebble into a perfectly still pool, the ripples would expand and eventually fade. But the pool would never be exactly the same. The water would hold slightly more energy. The molecules slightly rearranged. The surface tension forever changed. It's the same with space. The ripples of your presence are small, but they exist. They shape what happens next. Think about what that means on a larger scale. The stars in the sky aren't just points of light. They're massive objects bending space across light years. Their gravity shapes how other stars move, how planets form, how galaxies rotate. And even when a star dies, its gravity doesn't disappear instantly. It continues to shape the motion of everything around it. That's how black holes can form, not as destructive vacuums, but as the natural continuation of a star's gravitational influence. And black holes take this even further. Their curvature is so extreme that it creates a boundary, an event horizon, beyond which nothing can escape. But even then, the memory remains. The gravitational pull of the black hole affects everything around it, not just nearby, but across space. The black hole doesn't act, it simply shapes, and that shaping is a kind of persistent memory. It might seem strange to call gravity a form of memory, but what else would you call something that preserves the structure of the past and determines the path of the future? And if gravity records everything that has weight, everything that has mass, then it's been recording from the beginning, from the first clumps of matter after the Big Bang, from the formation of the first stars, from the swirl of gas that would one day become Earth. Every movement since then has been influenced by every movement before it. You exist in the middle of a long, continuous gravitational story. You're shaped by it, and you shape it in return. Even when you sleep, even when you lie still. That's not metaphor. That's not romanticism. That's just how mass and space behave. You have gravity, so you have influence, so you leave a record. You don't need to do anything. You already are. So when people say the universe is indifferent, that space doesn't care, that it doesn't notice what we do, there's some truth in that. It doesn't assign meaning. It doesn't judge, but it does respond. It reshapes. It shifts. It holds on. It doesn't let go. And that's what we're surrounded by. Not a void, not an emptiness, but a structure, a field, a fabric that bends with us because of us. A quiet background that listens not with ears, but with geometry. That's what gravity really is. The space between stars is often called empty, but that word doesn't really apply. It's a convenience, a simplification. It helps us talk about the vastness between objects without needing to explain the details. But if you paused for a moment and looked closely, not with your eyes, but with the right instruments, you'd see that even the quietest parts of the universe aren't silent. Even where there seems to be nothing, something remains. What fills that space isn't sound. It isn't wind or motion in the way we're used to. There's no breeze across the vacuum, no whisper in the air. But something does pass through, and it leaves a trace. That trace, however faint, is an echo. Not in the way we usually understand the term bouncing off walls or mountains, but in a more fundamental way. A continuation of something that happened, stretched across distance and time. Out in interstellar space, far from any star or planet, the density of matter is incredibly low. just a few atoms per cubic centimetre, sometimes less. From a human perspective, that's close enough to zero to feel like nothing. But those atoms matter. They move, they carry charge, they're influenced by electric and magnetic fields, and they don't stay still. Their motion holds memory of collisions, of light that pass by, of nearby explosions, of ancient supernovas. Some of that space is filled with radiation, microwaves, radio waves, X-rays, all drifting outward from past events. A star that exploded 10,000 years ago in a galaxy you'll never see still sends out light and particles. They don't vanish when no one's looking. They just keep going. The energy released in that moment continues outward, endlessly, unless it's interrupted. Every burst of energy, every pulse, every photon that doesn't hit something keeps travelling, which means that so-called empty space is actually full of old signals. They're weak, yes, faint enough to need incredibly sensitive equipment to detect, but they're real, and they're everywhere, even here, surrounding you now, invisible to your eyes but not gone. The Earth doesn't shield you from all of it. Much of it passes through walls, through buildings, through your body, and if you had the right kind of detector, you could read it. That's part of what makes our observatories so powerful. Instruments like radio telescopes aren't just looking at stars, they're listening to the in-between. They're picking up ancient radiation, the leftover noise from things that happened so far away we've only just begun to notice them. The quietest parts of the sky aren't blank. They're filled with overlapping histories, signals so faint they seem like background until you start to separate them. This is how we discovered the cosmic microwave background, the faint glow from the birth of the universe. Not by pointing at a galaxy or star, but by measuring the space between. It wasn't a bright flash. It wasn't even a sharp line. It was a faint, uniform hum in every direction. A leftover signal, an echo from when the universe was only a few 100,000 years old. That signal hadn't disappeared. It had been travelling the whole time, and when we finally built instruments quiet enough to hear it, it was still there. The echo of the beginning still bouncing through space. Now, it's not only light that travels, particles do too. Cosmic rays, neutrinos, high-energy fragments of atoms, all of them journey through space for millions, sometimes billions of years. Some are created in the hearts of stars, some in black holes, some in distant galaxies, and most of them pass through everything they encounter. That includes you. Every second, countless particles, especially neutrinos, pass through your body without ever interacting. You'll never feel them, you'll never know they were there, but they carry energy, and that energy comes from events long gone. The universe doesn't keep things in one place. It spreads them out. It distributes what happens like ink in water. The moment doesn't end when the star explodes. It continues, softened, thinned, but always moving, and that's what makes empty space interesting. Not because of what it lacks, but because of what it contains quietly. Even gravity reaches into that space. The curvature of distant masses still has an effect. When two black holes merge, for example, the gravitational waves that ripple out from the event are not confined. They move through space in every direction, including through the places we consider void, and when they pass, they stretch and squeeze the space itself, just a little, just enough to leave a mark, a permanent shift in the alignment of particles, a gravitational echo. You wouldn't feel it, not directly, but with the right tools you could measure it. That's how LIGO and other detectors found them, not by looking at stars but by watching laser beams change length. The change was smaller than the width of a proton, but it was enough to say that something had happened far away and its ripple had reached us. So space isn't just where things happen, it's how we know they happened. Even in the middle of nowhere there are echoes of ancient motions, of collisions, of things bending and snapping back into shape, of energy that once gathered, then dispersed. And just as we receive these signals, we also send them. Earth is not silent. Our planet emits infrared light, reflects sunlight, sends out radio waves. Human technology alone has flooded space with signals for over 100 years. Some of that has escaped into the universe, and like everything else, it continues outward. A television broadcast from 1953 is now over 70 light-years away. A radar ping from the Cold War is halfway to a nearby star system. Those signals degrade over distance, but they don't disappear completely. In theory, some alien civilization with a large enough dish could catch the tail end of one of our oldest messages. It wouldn't be clear, it might not even be readable, but it would be something. A footprint. A moment of Earth, stretched thin but still present. That applies to more than broadcasts. Every engine, every combustion, every burst of energy we create sends out some radiation. It might be too weak to measure now, but it leaves the planet just the same. So when we think of space as silent, that's only because we're used to sound needing air. But in space, silence doesn't mean nothing is happening. It only means we can't hear it in the usual way, and the echoes don't need ears. Space keeps them anyway. That's part of the strange beauty of the vacuum. It doesn't resist. It doesn't erase. It lets things move without interference, which means it preserves events in motion longer than almost any other medium. A sound on Earth fades quickly because it needs air. It needs friction. A signal in water or glass is eventually scattered. But a wave in space can last. If nothing gets in its way, it can cross the entire observable universe. Not because it's powerful, but because space lets it. In that way, space isn't passive. It's permissive. It carries. It holds on. It doesn't forget what passed through it. Not immediately. Not entirely. It keeps moving until something finally stops it. And so the universe, at any given moment, is full of events that haven't finished echoing yet. Things that happened long ago but are still in the process of arriving somewhere. Still shaping the background. That includes you, your signals, your heat, your electrical field. All of that extends into space. Maybe not far, maybe not strong, but enough to join the echoes. Enough to leave a trail. And this is what's fascinating. None of those echoes are coordinated. There's no editor, no archive. But the structure of space still holds them together. The fields, the curvature, the quantum states, they all respond. They all adapt. They all change slightly with every new interaction, which means memory doesn't need a mind. It just needs space that can be changed. And now that we know even nothing isn't really empty, it's worth asking, if the echoes are still out there, can we ever truly lose anything? Does forgetting mean the same thing if the universe keeps moving the evidence forward? Is silence really the absence of memory, or is it just a layer we haven't peeled back yet? These questions don't need answers tonight, but they can stay with you, quietly, like the particles that drift through your room, like the background radiation that warms your body ever so slightly, like the field that curves gently around your weight, holding you in place. The next time you look at the dark sky, try not to think of it as blank. Think of it as layered, full, alive with quiet evidence. If space can carry echoes, and if even the emptiest regions still hold on to the past in the form of ripples, waves, or particles in transit, then there's one place that seems to defy that pattern. One place in the universe where forgetting doesn't just happen, it appears to be the rule. Black holes. You've probably heard the basics. A black hole forms when something massive collapses under its own gravity, squeezing its matter into a point so dense that not even light can escape. It doesn't explode. It doesn't disappear. It folds inward, and what's left behind isn't a solid object or a hollow void. It's a region of space where gravity has won completely, where the slope of space-time becomes so steep that everything, light, matter, energy, falls in and doesn't come out. That makes them sound like cosmic vacuums, but they're not. They don't suck things in from across the galaxy. They just sit there, quietly, waiting for something to cross their boundary. That boundary has a name, the event horizon. Once something crosses it, escape is no longer possible, not because it's being crushed necessarily, but because the paths out no longer exist. All directions now point inward. That much is well understood. It's backed by observation, theory, mathematics. But something about black holes has always raised a deeper, stranger question. A question that doesn't fit easily into our understanding of physics. It's not about what they are, it's about what they do to information. Imagine throwing something into a black hole, a book, a particle, a beam of light. It doesn't matter. Once it crosses the event horizon, it's gone. You can't pull it back. You can't scan it, retrieve it, decode it. From the outside, the only thing you ever see again is the black hole's mass spin and electric charge. That's it. Not the details of what went in, not the composition, the structure, the identity. Just those three values. That's a problem. Because in the rest of physics, information is never supposed to be lost. You can scramble it, you can hide it, you can make it practically impossible to reconstruct, but it's still there. If you know every detail about a system, its state, its energy, its fields, you can, in theory, reverse it, work backward, recover what it was. That's called unitarity. It's a principle baked into the foundations of quantum mechanics. But black holes don't seem to allow that. They appear to erase the fine details, reduce everything that falls into them to just a few surface-level traits. If you dropped a page of writing and a clump of iron into the same black hole, the result would be indistinguishable. Just a tiny bump in mass, a slight change in angular momentum, a shift in electric charge, if any. The content gone, irretrievable, forgotten by the universe, which violates everything else we understand. Physicists call this the information paradox. It's not about whether black holes exist. We've observed their effects. We've watched stars orbit them. We've seen mergers in gravitational waves. It's about whether they violate the rules, whether they break the fundamental law that information, once written into the universe, never truly disappears. For decades, this was a source of debate, a quiet tension in the background of every black hole paper. And then, in the 1970s, Stephen Hawking made it worse, by making it more precise. He showed that black holes aren't entirely black, they radiate. Not through light escaping from inside, but through a quantum process at the edge of the event horizon. Pairs of particles can pop into existence near the horizon. One falls in, the other escapes. That escaping particle carries energy away, which means the black hole slowly evaporates. It loses mass. Over vast periods of time, it could even disappear entirely. And if that's true, if a black hole can fully evaporate, then all the information that went in seems to vanish with it. The book, the particle, the beam of light, none of them return. Their patterns, their structure, their identity, gone. Not just hidden, erased. That's the paradox. If black holes can destroy information, then quantum mechanics can't be fully trusted. If quantum mechanics is always correct, then black holes must keep the information somehow, somewhere. But where? For a long time, no one knew. Some said the information gets stored inside the black hole, somehow encoded in the singularity at its core. Others suggested that the information comes out with the Hawking radiation, but so scrambled, so randomized that it looks like noise. Still others proposed that the information is preserved on the event horizon itself, on a thin shell around the edge, a kind of memory surface, a ledger. That idea led to something bigger, the holographic principle. It suggests that everything inside a region of space can be described by information stored on its boundary. That the universe might work like a hologram, where the surface encodes the volume. Black holes inspired this idea, because if the only traits we can measure are on the surface, the horizon, then maybe the details are stored there too. Not destroyed, just projected. It's still theoretical, but the math works. It explains things that seemed impossible to reconcile. It preserves unitarity, and it gives black holes a kind of strange honesty. They don't forget, they just compress. The information is still there, it's just written in a language we don't fully understand yet. There's also something called black hole complementarity. It says that information isn't lost, it's just inaccessible, depending on your point of view. If you stay outside the event horizon, you can't retrieve what fell in. But from the perspective of the falling object, time behaves differently. The information might still exist in that frame. Both descriptions are valid, but they can't be accessed at the same time. No contradiction, just limits. Another idea, more speculative, suggests that black holes might not even have a true singularity inside, that instead, something happens at the core, something quantum, something unknown, that bounces or repels or stores. A memory structure, deeper than gravity. We don't know which of these is correct. Maybe none are. Maybe all of them in some way. But what's clear is this. Black holes aren't simple. They're not oblivion. They're not blank. They may be the most compressed, dense, hidden record keepers in the universe, and we're only just beginning to understand how they store what they consume. It's tempting to think of a black hole as forgetting, as the end of a story, as a page torn from the book and burned. But even fire has rules, even fire leaves ashes, even combustion follows laws, and gravity, despite everything, obeys structure. It bends space, it shapes time. It doesn't just destroy, it transforms. So maybe what we call forgetting is something else. Maybe it's a kind of compression, an encoding so complete we can't decode it yet. Maybe the information isn't gone, it's just locked behind a boundary we don't yet know how to open. And this matters because the universe as a whole is full of transformations. Stars collapse, matter combines, energy radiates. Nothing stays in its original form, but every transformation follows rules. Every outcome follows from an earlier input. If information were ever truly lost, if something could disappear without trace, then prediction itself would break. Cause and effect would become uncertain. The structure of physics would start to unravel. That hasn't happened. Even black holes, with all their mystery, still follow the mathematics, still leave clues, and maybe in a way they remind us that forgetting is never complete, that what we lose might still exist, that silence doesn't mean erasure. If black holes can store the memory of everything that falls into them on their surface, not inside, then something strange opens up. Not just about black holes, but about everything. If the information about a volume of space can be preserved on its boundary, maybe that's not just a black hole thing. Maybe it's how space works everywhere. That's the root of what's now called the holographic principle. It's not a metaphor, it's a serious proposal in physics, and it began with the problem of information and black holes, because when physicists tried to calculate how much information a black hole could contain, they found something surprising. The limit wasn't based on the black hole's volume, it was based on its surface area, not how much was inside, but how much was at the edge. That breaks with our everyday logic. We expect the contents of a space to scale with how big it is inside. You fill a room with boxes, you measure a pool by how much water it holds. But with black holes, it doesn't work that way. The maximum amount of information they can store is proportional to the area of their event horizon, not the volume inside it. The surface holds the key. So physicists started to ask, what if that's true not just for black holes, but for the universe itself? That's the holographic idea, that the entire volume of space, everything you experience, every particle, every event, might be fully described by information encoded on a distant surface, a kind of boundary, a cosmic screen. It sounds abstract, but it has mathematical support. In certain models of space, especially ones with negative curvature, you can take a system of gravity in 3 dimensions and describe it perfectly with a system of particles and fields on a flat two-dimensional boundary. The physics match. The behaviour is the same. It's like having two languages that tell the same story, even though they look completely different. One is space with gravity, the other is a surface with no gravity, just interactions. And if that holds, it means that everything happening inside the universe might actually be a projection of information that lives on its edge. Not like a movie screen, not as an illusion, but as a mathematical equivalence. What happens in the bulk of space is fully accounted for by what's stored on the surface. No loss, no contradiction, just a different way of seeing. If that's hard to picture, that's fine. It's hard to picture for everyone. We're not used to thinking of reality that way. But in some ways, it fits better than the alternatives. It solves problems in quantum gravity. It keeps unitarity intact, and it makes sense of how black holes could store what they consume. In this view, the event horizon of a black hole isn't just a point of no return, it's a ledger, a record-keeping surface. What goes in is encoded there, not necessarily in a readable way, not with bits or symbols or labels, but encoded in the fine structure of the horizon itself, its fluctuations, its geometry, its quantum pattern. The inside doesn't disappear, it just becomes invisible. The information isn't lost, it's flattened. Now, if that works for black holes, the natural extension is to ask, what's the boundary of our universe? And that's where the ideas get even more abstract. Because our universe doesn't have an edge in the usual sense. It's not a balloon with a skin or a dome with walls. It's more like a volume that expands indefinitely, with no centre, no edge to fall off. But in certain models, especially those that look at the universe as a kind of dynamic curved space, it's still possible to define a boundary, not in physical space, but in the mathematics, a kind of limit at infinity, a region that contains all the information about what's inside. So the holographic principle doesn't need a literal wall, it just needs a surface that encodes the content of the space, and from that surface you could, in principle, reconstruct everything happening inside, not just the positions of stars and galaxies, but the quantum states of particles, the behaviour of fields, the evolution of time, your hand moving, a star flickering, a thought forming, all of it theoretically written on the edge. It's not proven, not for our actual universe. But the idea is serious enough that entire fields of physics have emerged to study it, and it has weight because it connects gravity and quantum mechanics in a way that few other ideas can. It treats information as fundamental, not a byproduct, not an interpretation, but the core ingredient. The holographic view says that information is not only preserved, it defines what exists. If that's true, then the universe isn't made of matter first, it's made of information first. Matter and energy are expressions of that information. The rules aren't in what things are, they're in how things relate, in the structure that emerges from the encoded data, that reshapes the way we think about memory. Because if information is fundamental, then memory isn't something only brains do, it's something space does, something nature does, something reality can't avoid doing. You move through a room, you leave a trace in the fields around you, you shift the configuration of matter. The boundary, if it exists, now has that motion encoded. You sit still, you breathe, you let time pass, the state of space updates, and that update is not deleted, it's part of the whole. So the question of whether the universe remembers doesn't rely on some cloud of mystical awareness or cosmic storage. It relies on this idea that everything is information, and information is conserved, even when you forget, even when your mind drifts, even when your thoughts fade. The underlying pattern of your presence continues to exist, not as a backup, not as a perfect replica, but as a contribution to the total state of the universe. You're not isolated from the rest of space, you're entangled with it. That's not metaphor. In quantum mechanics, entanglement is a real, measurable phenomenon. Two particles can share a state such that changing one instantly affects the other, no matter how far apart they are. Their properties are correlated in a way that no classical system can explain, and the more things are entangled, the more they share information. Some physicists believe space-time itself might be built from entanglement, that the structure of the universe, the distances between things, the shape of gravity, emerges from networks of entangled information. That space is not a stage where things happen, but a product of how information is organized. If that's true, then memory isn't layered on top of reality. It is reality. The separation between past and present isn't absolute, it's relational. It depends on how the information is accessed, what's visible, what's entangled, what's been decohered, and what hasn't. And in that view, forgetting is never complete. Not because you remember everything, but because the system does. The totality remembers. It just doesn't present all of that memory in one place. You see only a slice, a moment, but the whole is still there. And if that's overwhelming, let it be. Let it sit quietly beside you as you rest. You don't need to understand every equation. You don't need to visualize the edge of the universe. Just know that you're part of it. That you're not outside the pattern. You're written into it. Not recorded as a separate file, not copied and backed up. Just present, interwoven. So if you've ever wondered whether your smallest actions matter, or whether your presence is noticed in any real way, physics says yes. Not in a grand, performative way, but in structure, in state, in encoded shifts across the surface of what is. You've probably heard the word entropy before, maybe in the context of disorder, of things falling apart, of time moving forward. It's one of those concepts that gets borrowed a lot. People talk about entropy in culture, in relationships, in cities. But in physics, entropy has a specific meaning. And it's not just about chaos, it's about information. Entropy measures the number of ways a system can be arranged while still looking the same on the outside. It's a count of possible configurations, a measure of what you don't know. Take a simple example, a deck of cards. When the cards are neatly ordered, ace through king, suits grouped, you know exactly where everything is. That's low entropy. But once you shuffle it, the number of possible arrangements skyrockets. From the outside, the deck still looks the same. Same size, same shape, but your knowledge of what's inside has dropped. That's higher entropy. The same idea applies to physical systems. When you have a container full of gas, for example, and all the molecules are moving in random directions, you can't predict where any single one is without measuring it. The total energy might be known, but the fine details are missing. That's entropy. It's a measure of the information you've lost or never had about the precise state of the system. And here's the important part. Entropy almost always increases. That's one of the most fundamental rules in physics, the second law of thermodynamics. In an isolated system, entropy doesn't go down. It either stays the same or goes up. Things spread out. Structures decay. Order becomes harder to maintain. Ice melts, smoke disperses, memories fade. Not because there's a force pushing them apart, but because there are more ways for things to be disordered than to be ordered. There are more microstates than patterns. The universe naturally flows from low entropy to high. This is one of the few physical laws that has a direction. Most equations in physics are time-symmetric. They don't care whether you run them forward or backward, but entropy breaks that symmetry. It gives time an arrow. That's why you remember the past but not the future. Why footprints appear behind you, not ahead. Why a glass shatters but doesn't reassemble. Entropy doesn't make things impossible. It just makes them unlikely. The ordered states are fewer. They require specific conditions. Once those conditions are gone, they don't come back on their own. So when people say that time is just an illusion, that it's a dimension like space, that the universe could be static, entropy quietly disagrees, because we experience the flow of time as a change in entropy, as a shift from low to high, as a loss of structure, a dilution of information, a spreading out, and that has consequences. Every time you remember something, your brain creates patterns, connections between neurons, a specific arrangement of molecules that's a low entropy state. It's vulnerable. It takes energy to maintain, and over time that energy depletes. The patterns degrade, not immediately, but slowly. That's why memories fade, not because you didn't form them well, but because they are structures, and structures are fragile. This applies beyond biology. Even a computer storing data must fight entropy. It uses energy to write and preserve information, to keep bits aligned, drives spinning, temperatures stable. The moment power is lost, the memory starts to decay. The structure unravels. That's entropy, the natural pull toward less distinction, less specificity, more possibility, less certainty. So the cost of keeping anything remembered is energy, and the cost of forgetting? Nothing. It happens on its own. You don't have to do anything to lose a pattern, you just have to let it sit, let it drift, and the universe will do the rest. That might sound bleak, but it's not necessarily, because entropy also allows for change, is what drives movement, reaction, adaptation. Without it, everything would stay static, frozen in place. There would be no flow, no progression, no difference between moments. Entropy gives time its texture, its asymmetry, its meaning. But it does mean that memory is temporary, not because it's fragile in essence, but because it exists in a system that tends toward forgetting. And yet, some things resist, some structures hold, stars burn for billions of years, atoms remain stable, crystals persist. Even DNA, over generations, keeps its pattern, not forever, but long enough. Long enough for meaning to emerge, long enough for complexity to build, and in some systems, memory is built into the structure. You've seen this in the marks on a surface, a tree with rings, a rock with wear, a fossil with shape. Each one is a record, held against entropy by the stability of matter, by the persistence of form. They're not immune to decay, but they last, and in that span they preserve what happened. That's the balance. Entropy pulls toward forgetting. Systems push against it to remember, not always intentionally, often by accident, but the result is the same. Some memories survive. The same is true of you. Your body maintains its form against entropy, at least for a while. Your thoughts emerge from the patterns in your brain. Your habits, your reactions, your posture, all of them are forms of memory, physical memory, stored not in symbols but in repeated structure, and each one takes work to preserve. That's why rest matters, why sleep matters. Because maintaining form in a world of entropy requires repair. It requires order to be rebuilt, slowly, constantly. And it's not just human. Galaxies do it too. Their rotation, their spiral arms, their structure, they're a kind of memory, of gravitational balance, of earlier motions, of past collisions, not perfect records, but persistent ones. So when you think about forgetting, not just personally but cosmically, it's not about destruction. It's about diffusion, not about absence, but about change. The signal doesn't vanish, it spreads. The pattern doesn't die, it becomes less distinct, and in that something else can emerge. That's the strange thing about entropy. While it leads to forgetting, it also creates the conditions for new memory to form. A star collapses, and a black hole is born. A system decays, and its particles recombine. Information doesn't disappear, it redistributes. That's why the laws of physics never say memory is impossible. Only that it's expensive, you can remember. But it costs energy, it costs time, it costs structure, and in a universe that keeps expanding, that keeps stretching space itself, those costs keep rising. The cosmic background radiation, for example, started as bright light, high energy, dense information. But as space expanded, that light stretched, it redshifted, it cooled. Now it's microwave background noise, still full of history, but faint, diluted, A high entropy record, still there, but harder to hear, so memory doesn't disappear. It becomes harder to read. Time is the one thing you're always moving through, even when you don't notice it. You don't have to do anything to pass through it. You can sit still, say nothing, close your eyes, and it keeps going. That motion, quiet and constant, is your context, and you share it with everything else. It's not just that you experience time, you're made from it. Every process that shaped your body, every cycle in your cells, every memory in your brain, it all depends on time passing, and not just any kind of time, but one that moves in one direction, forward. That forward motion isn't just habit, it's structure. You eat, then digest. You sleep, then wake. You remember, but only after something happens. That sequence is never optional. It's not because of how your brain is wired. It's because of how the universe is wired. Time flows one way because entropy flows one way. The future has more possible arrangements than the past. But what does that really mean? It means time, in practice, is a record. A structure that keeps track of change. Without that change, there's no way to tell one moment from the next. If everything were frozen, no particles moving, no fields shifting, no processes running, then time might still exist, but you wouldn't know it. There'd be no difference between then and now, no data to compare, no memory to access. So memory and time are not just connected, they depend on each other. You can't have memory without time because memory is about storing something that used to be true. And you can't have time without some kind of change, something that marks the difference between now and then. That's why the universe seems to remember, not because it writes things down, but because it carries the trace of what happened through time. The state of things now reflects the state of things before. Not perfectly, not completely, but consistently. The shape of a galaxy reflects the motion of matter billions of years ago. The energy of a particle reflects what it interacted with moments before. It's all connected through cause and effect. Time is the network that links those causes and effects. Not in a straight line, but in a continuous field. And you are part of that field. Everything you do adds to the timeline. Every action leaves a mark. Even in silence, even in stillness, time carries the signature forward. That's how memory works at every level. When a rock falls into a river, the splash is temporary. But the erosion, the new shape of the bank, that's a memory. When light passes through a cloud of gas, the atoms absorb and re-emit specific wavelengths. That's a memory. When two particles interact and recoil, their trajectories carry the mark of that interaction. That's a memory too. And none of this happens outside of time. It happens because of time. That's why it's helpful to think of time not just as a line, but as a kind of medium. Something that surrounds you. Not visible, not solid, but always there. Not something you ride through, but something you are immersed in. A dimension you swim in without touching the bottom. You feel this when you reflect. When you think back on a moment and recognize that it's past. That it was once present. And now it isn't. That distance between the experience and the recollection, that's time. You don't create it, you inhabit it. And it's not the same everywhere. Time moves differently depending on how you move and how close you are to mass. That's part of general relativity. Gravity slows time, so does speed. An astronaut orbiting Earth ages more slowly than someone on the surface. A clock on a mountain ticks faster than one at sea level. These effects are small but real, measurable. GPS satellites have to account for them to function correctly. If they didn't, your phone's location would drift by kilometers every day. This tells us something important. Time isn't absolute. There's no single now that stretches across the universe. There's no master clock that keeps everything synchronized. Time is local. It bends and shifts depending on where you are, how fast you're going, and what's around you. But within each frame, each experience, it feels continuous. You feel your own passage through time, steady and personal. You build memories as you go, and you compare new experiences against those memories. That's how you construct meaning. That's how you decide what matters. Time is the medium where meaning accumulates. Even particles use time. A particle travelling through space has a history. It has a trajectory, a spin, a decay rate. Those properties evolve. They're not static. They mark the passage of time at the smaller scales, and together they tell a story, not with words, but with change. In that way, everything in the universe has a timeline, not just living things, not just conscious things. Everything, every star, every atom, every event. And those timelines intersect. When you touch something, the histories combine. You leave a trace and receive one in return. When you speak, your words ride the air, carried by particles that have their own motion, their own past. When you look, the light reaching your eyes has been travelling for some time, often from far away. That light brings a piece of the past with it, so you're always interacting with time, not just passing through it, but modifying it, locally, briefly, in the patterns you leave behind. That's what makes memory possible, not just in the mind, but in matter. Your brain remembers in a biological way. Neurons connect. Signals fire. Chemical pathways strengthen or weaken. But those changes are physical. They happen in time. They carry forward. That's why you can recall something that happened years ago, because the structure has lasted. The timeline didn't break, and the same applies to the universe. The structure lasts. Not in perfect detail, not in infinite clarity, but enough. Enough to build stars, to form elements, to sustain orbits, to evolve galaxies. All of that depends on continuity. Even randomness, true quantum uncertainty, doesn't erase continuity. It adds variation, but not chaos. The underlying system still evolves according to the rules. Time flows forward, the wave function changes, measurements collapse, but the field remains. The timeline is preserved. So if you think of time as a river, you're not wrong. But it's a river that carries information, not just movement, not just duration, but structure. The past doesn't vanish, it accumulates. That's what history is, not just stories, but the physical memory of the universe, encoded in rocks, in radiation, in rotation, in you. You're not separate from the timeline, you're an extension of it, a continuation. The patterns in your body reflect billions of years of chemical evolution, biological adaptation, planetary motion. You're composed of moments that preceded you, and you will continue into moments that follow. Even your silence becomes part of that continuity. You don't need to remember everything. The universe does that. Not as a person, not as a consciousness, but as structure, as persistence, as time. So while you drift here, surrounded by quiet, let that be enough. Let the timeline carry you, and as we move forward, we'll begin to look more closely at how those patterns take shape in you. How memory isn't just stored in thought, but in substance. How your very atoms, quiet and unthinking, still carry records of the stars they came from. By now you've heard that your body's made of stardust, that the carbon, the calcium, the iron in your blood all came from older stars that lived and died long before the Earth formed. That's true, and it's extraordinary. But what's often missed in that fact is what it means on a deeper level. It means your body isn't just made of matter, it's made of memory. Not memory the way your brain keeps it. No photographs, no dates, no names, but memory as a sequence of conditions that have been met. A long line of events that had to happen in exactly the right way for you to exist. And those events are not simple. They are complex, layered, and precise. Start with a single atom in your body. Pick one. A nitrogen atom in your bloodstream or a phosphorus atom in your DNA. That atom wasn't made on Earth. It wasn't formed in the body of your parents. It came from a process in a star that burned billions of years ago. A star that collected gas, grew dense, reached the temperatures and pressures necessary to forge new elements in its core. That forging took time. That star had to live a certain kind of life, then die in a particular kind of way. Its death had to scatter its contents, and those contents had to mix into a cloud of gas that eventually condensed into a solar system. That solar system formed planets. One of them was Earth. And on Earth, chemistry happened. Slowly, consistently, with just enough variation to support life. Your atom followed that entire path. Not alone, but as part of an enormous chain of matter. And that chain didn't break. The atom made it into you. So that atom is a record. Not a metaphor, not poetry. A literal physical record of all the conditions that came before. It's here because of what happened then. It survived stars, space formation, atmosphere, digestion, cell division. Its existence now is the result of continuity. So when you think of memory, include this too. Your structure holds more than your life. It holds history on every level. Your DNA is a story too, though a different kind. It's a chemical sequence that can replicate, a molecule that holds instructions, and those instructions have been passed down, generation by generation for billions of years. The shape of your proteins, the design of your cells, the ways your body heals and grows and ages, all of it is built on patterns that were copied, modified, and copied again. Some of those patterns go back to the earliest life on Earth, to single-celled organisms in oceans long gone. The sequence has shifted over time, but not randomly. Changes that didn't work were filtered out. Changes that worked were kept. And now, in you, they continue. You are not the first version. You are the current one, and the memory in your body is what made that possible. You might not know how to read DNA. Most people don't. But that doesn't make it less readable. Scientists can look at your genome and find shared markers with distant populations. They can find evidence of ancient viruses embedded in your chromosomes. They can trace your ancestry through the changes in your mitochondrial DNA. All of that is memory, encoded chemically, not consciously, and that's just the biological layer. There's also physical memory, the way your bones grow, the way your muscles hold posture, the way your immune system reacts. These are learned responses, accumulated experiences. The structure of your body has changed over time, depending on what you've encountered, what you've endured. You carry scars, not just visible ones but cellular ones, chemical adaptations, shifts in regulation, signals passed between organs based on prior exposure. That's memory too. It doesn't require awareness. It doesn't need permission. It's just what happens when structure meets time. Even your senses carry stories. Your ability to see is the result of light-sensitive proteins that evolved to detect patterns in the environment. Your ears respond to pressure waves because the tiny bones and fluid channels inside them formed a long time ago, shaped by the demands of a changing world. Your brain interprets these inputs by comparing them to patterns it's already learned. Memory is not something you switch on. It's embedded in how you perceive. And all of this, every cell, every atom, every function, rests on older stories, on chemical bonds that form only because the laws of physics allow them to, on physical constants that don't change, on particles that behave the same way today as they did at the birth of the universe. That consistency is its own kind of memory, not in the sense of recording specific events, but in the sense of preserving rules. The fact that electrons still carry the same charge, that photons still travel at the same speed, that gravity still curves space, that's the most basic form of memory there is. Without it, nothing could last. Nothing could evolve. Nothing could mean anything. So when you lie down and feel the weight of your body, it's not just gravity you're feeling, it's a summary, a compression of everything that had to happen for your body to be here, on this planet at this moment. It's not poetic, it's physical. Your body obeys rules that were written before you were born, and those rules allow it to preserve structure, to survive, to respond. That's what makes you more than matter, not because you're separate from it, but because you contain its history. And in that history, you are not the center, but a part a continuation of a much longer line, a story that doesn't start with you and won't end with you, but includes you as a critical scene. That's why the idea that you're made of stories is not just a nice phrase, it's a factual one. You're built from sequences, from interactions, from convergences that had to align. You're not random, you're not unconnected, you're assembled, and the longer you look, the more that becomes obvious. Not because everything has a purpose, but because everything has a past, and that past is accessible, traceable, embedded in structure. That's the kind of memory that never needed to be remembered by anyone. It just needed to be carried. And your body does that. Quietly. Without asking. Even when you're asleep. Even when you forget. That continuity isn't always comforting. It means pain can be passed down. It means trauma leaves marks. It means habits, mental and physical, can become patterns over generations. But it also means growth is possible. That healing can be structural too. That new stories can be written. Because memory is not only about what was kept, it's also about what can be changed. At the smallest scale, memory gets strange. You're used to thinking of matter as stable, solid, predictable, quiet. A chair stays a chair. A stone doesn't change unless something acts on it. But beneath the surface of every object, including your body, matter behaves very differently. Not chaotic, but far less settled than it seems. Constant motion, constant interaction, and each interaction changes something. So the question becomes, does matter, in its most basic form, remember where it's been? A particle, like an electron or a quark, doesn't have thoughts. It doesn't write anything down. But it does have properties. Mass, spin, charge. These don't change randomly. They persist. That's already a kind of memory, a way the particle retains identity over time. But beyond identity, there's also interaction. When two particles meet, they don't just pass through each other. They interact according to specific rules. They exchange momentum. They exchange energy. And those exchanges leave marks. Not visible ones, but physical ones. The particles that emerge from the interaction are different. They move in different directions. Their paths reflect the event. That means what a particle is doing now contains information about what it did before. You can't rewind the universe perfectly, but in many cases you can work backwards from a particle's current state and make a good guess about how it got there. That's not because of intuition, it's because of physics. Conservation laws of energy, momentum, angular momentum are like the grammar of the universe. They tell you what can and can't happen, and they're strict. Without them, prediction would collapse, but with them, memory emerges. Not memory as storage, but as constraint, as continuity. The particle can't just forget its past, its current behavior depends on it. Now, take a larger view, a particle bouncing inside an atom, that atom vibrating in a molecule, that molecule part of a cell. The behavior of matter at each level is layered, but it all stems from the quantum interactions of particles, those tiny, fleeting exchanges that accumulate into structure. And those interactions carry a record. Again, not in writing, but in position, velocity, field strength. Each electron orbiting an atom does so based on probabilities. It doesn't follow a fixed path like a planet, but its distribution, its shape, its likelihood of being here rather than there, is determined by energy levels. And those energy levels depend on everything the atom has experienced, the bonds it's formed, the forces it's felt. In that way, the electron's state is a summary, a diary entry made not in words but in shape. Even a collision between atoms doesn't go unnoticed. They deform, they scatter, they leave each other altered. Slightly, maybe, but altered. That alteration persists. Unless something else comes along to undo it, it stays. Matter keeps the shape it's been given. Not always forever, but for long enough. Crystals grow in patterns determined by how their atoms arrange. That arrangement depends on temperature, pressure, impurities, on environment. And when you look at a crystal, you can see those influences. You can measure the faults, the angles, the inclusions. They're not defects, they're records, tiny physical annotations of what happened during formation. Even in metals, stress leaves traces. Stretch a beam, it bends, the particles shift. Some dislocations are reversible, some aren't. Those that aren't become history, locked into the lattice. If you know what to look for, you can read the forces that shape the object long after they're gone. That's material memory, and you can go even smaller. In quantum physics, particles don't just have properties, they have states, and those states evolve. In isolated systems, this evolution is deterministic. If you know the initial state exactly, you can predict how it changes. But here's the catch. Most systems aren't isolated. They're open. They interact with their environment. That interaction leads to decoherence, and decoherence is what makes quantum systems start to look classical. It's also what makes quantum memory fragile. The moment a system interacts with the world, it loses some of its fine structure. Not all at once, not completely, but enough. The more interaction, the less isolation. The less isolation, the less coherence. That's why quantum computers are so delicate. They need systems that can stay isolated long enough to preserve a specific state, a quantum memory. If too much decoherence occurs, the memory collapses into noise. So yes, particles can keep a record, but only briefly, only in the right conditions. The smaller and more precise the system, the more easily it forgets. And yet, at larger scales, the reverse is true. Because even though the underlying particles are fluctuating, the patterns they form can be stable. A rock remembers being shaped. A tree remembers growing. Your hand remembers learning how to hold a pen. Not because the atoms are fixed, but because the overall structure is reinforced. It persists. Matter doesn't keep memory like a book. It keeps it like a river keeps a bend. Like a canyon keeps an echo. Through shape, through response, through constraint. Even radiation carries memory. When a particle decays, it emits energy. The type and direction of that energy depends on what the particle was. You can measure the radiation, and from that infer the original state. That's how we study stars, supernovas, ancient isotopes in rock. That's how we know how old the Earth is, the decay of uranium, the layering of carbon. The rate of change tells a story one atom at a time. So again, the answer is yes. Matter keeps a diary, not in symbols, but in structure, not in words, but in relationships. Every interaction changes something. Every change adds to the record, and that record persists, as long as the system does. Even temperature is memory. A hot object has energy distributed among its particles. That energy came from somewhere. A flame, sunlight, friction. The heat isn't just sensation, it's history. It tells you something happened. Something added energy to the system. And until that energy is lost, the memory remains. That's what makes your surroundings so full of silent information. A cup with condensation remembers a change in temperature. A door that sticks remembers moisture in the air. A worn-out shoe remembers every step. And you, without thinking, read these things constantly. You notice the softness of a surface, the weight of an object, the resistance of a button. You don't always realize you're reading memory. But that's what it is, encoded in the material world, stored in arrangements, retrieved through contact. When you get small enough, past molecules, past atoms, down to particles, you reach a place where the rules stop looking familiar. Things don't move in straight lines anymore. They don't have exact positions or definite speeds. They exist in probabilities, in chances, in shadows of what might be. This is quantum mechanics. It's not new, but it still feels strange. Not because it's unknowable, but because it doesn't behave like the world we can touch. In the quantum world, certainty is limited. You can know one thing but not another. You can measure position but then lose track of momentum. You can measure energy but then give up precision in time. These are not errors, they are fundamental features. And memory here becomes more delicate. Because to measure a quantum system, to observe it, you must interact with it, and interaction changes it. A quantum system left alone evolves smoothly, governed by the Schrödinger equation, like a wave unfolding over time. But the moment you look, the wave collapses. You don't get a blur, you get a result, a value, a moment, and the rest of the possibilities vanish. That's what makes memory in the quantum world so fragile. You can keep a state, preserve it, maintain its coherence, but only if you isolate it completely. Any interaction, even a stray particle or a flicker of heat, is enough to collapse the system into a single outcome. One possibility realized, the rest erased. That collapse is not destruction, it's transition. The wave function doesn't vanish into nothing. It becomes something definite, but in doing so, it loses the rest of itself. It forgets its own shadow, and that's what quantum shadows are. The parts of a system that could have been, but now aren't. The probabilities that were real, but unchosen. The alternate paths that existed until the moment you made a measurement. Once you ask the system a question, it gives you one answer and discards the rest. That's not how things work at our scale. When you flip a coin, it lands on heads or tails. But that outcome didn't delete the other possibility. You could flip again. You could trace the motion. You could analyze the forces. But in the quantum world, the moment the choice is made, the alternatives dissolve. And yet, those shadows matter. They shape what's possible. They define the range of what can happen. And even though they disappear when a decision is made, they were real, measurable, testable. Just not in isolation, not individually, you can't point to one. But you can see their effect in groups, over time in interference patterns, in entanglement, in probability distributions. That's why we say quantum systems are never just particles. They're also waves, and those waves leave traces, not in space, but in the structure of outcomes. You've probably seen the famous double-slit experiment. A single particle, like an electron, is fired at a barrier with two slits. If you don't measure which slit it goes through, it acts like a wave. It interferes with itself. It creates a pattern on the screen behind the barrier, a series of light and dark bands. That pattern only forms if the particle doesn't decide, if it keeps its shadow open. But the moment you measure which slit it goes through, the interference disappears, the pattern flattens, the wave becomes a particle. One path, one story, the rest forgotten. Not by accident, by necessity. The act of observation is also the act of writing over the uncertainty. So in this world, silence isn't nothing. It's potential, a state not yet asked to choose, a system not yet pinned down. And when left alone, that system holds on to everything it could become. That's quantum memory, not as a copy of what happened, but as a map of what might still happen. This is also what makes entanglement so strange. Two particles can become connected in such a way that measuring one affects the state of the other, instantly, no matter how far apart they are. The outcome of one depends on the outcome of the other, not through a signal, not through a force, but through shared state, a shared history, a memory between them, too deep to be seen, but too real to be ignored. When entangled particles separate, they still carry that connection, a kind of mutual shadow. You can't see it directly, but when you measure one, you collapse both. And the outcome obeys rules that reflect their shared past. That's not magic. That's not mind reading. It's memory, embedded in quantum correlation. And that memory is surprisingly resilient. It doesn't degrade over distance, but it does degrade with interaction. Like all quantum systems, entanglement is fragile. If you want to keep it, you have to protect it, shield it, insulate it from noise, That's why quantum computers are hard to build. They rely on maintaining superpositions and entanglement long enough to do something useful. Calculations, simulations, encryption. But every calculation is a balance between memory and disturbance, between keeping the shadow intact and finally reading the result. And the moment you read it, the shadow disappears. But it was real. You don't have to believe that. You can test it. Quantum mechanics is not philosophy. It's measurement, it's statistics, it's mathematics that predicts results to extraordinary precision. But its predictions are not always about things. They're about chances, and those chances leave marks. That's what a shadow is here. A probability that's structured, a pattern that's more than random, a silence that's more than blank, and that idea that the deepest level of nature keeps memory as a cloud of possibilities means that forgetting at this scale happens differently. Not all at once, but suddenly. When the system collapses, it loses not only what it could have been, but also how long it waited. Time in the quantum world doesn't pass like ours does. Between measurements, time is continuous but undefined. The particle exists as a function, not as a dot. Its motion isn't a path, it's a distribution. Only when you look does it become a point again. So what's remembered? What's lost? In one sense, everything. The coherence, the spread, the options. In another sense, nothing. Because the collapse creates something new. A new state, a new configuration, a new set of future possibilities. The shadow ends, the particle remains, and from that new particle a new shadow begins. That's the rhythm of matter at the quantum level. Memory not as archive, but as unfolding. You don't get a timeline of steps, you get the current state. From that, the rules apply, and from those rules the next possible states emerge. The particle doesn't look back, it doesn't carry regret, but it also doesn't act without history. The structure of now contains the trace of before. And so the universe continues. Possibility, then collapse, shadow, then signal, uncertainty, then clarity. There's a point where the small becomes large again, where the quantum gives way to the biological, and the biological begins to ask questions. You live at that scale, where molecules build cells and cells build patterns that can think. You don't observe the world passively, you interpret it, you reflect, and that introduces something new. Not just structure, not just interaction, awareness. You're not the only part of the universe that responds to input. A leaf moves when wind passes through it. A rock heats when sunlight touches it. But you do something different. You experience it. You track it. You form memory from it. And then you build something on top of that memory. Meaning. The patterns in your brain are not fixed. They change constantly. Neurons fire, connections strengthen, some fade, some loop. The system adapts, and in that adaptation, you get thought. That process is physical. It's not magic. Your brain obeys the same laws as everything else. Its signals are chemical. Its structures are made of atoms. Its functions can be studied, measured, mapped. But when enough structure exists, something emerges from it, something recursive, the ability not just to respond to the world, but to reflect on the response. You don't just feel warmth, you remember how warmth feels. You don't just see light, you recall where you saw it before. That recursive loop, awareness feeding back on itself, is what gives rise to memory as you know it. And in that memory, something else appears. Identity, a sense of self stretched across time. So now the question opens wider. If the universe remembers, and you are part of it, then is your memory just a small part of a larger process? Is your mind one thread in a larger fabric? There's no direct answer, but there are patterns worth noticing. The structure of the cosmos, when mapped, shows filaments, nodes, voids. Galaxies cluster along strands, forming webs of gravitational interaction. These webs stretch for hundreds of millions of light years. They are not random. They resemble something familiar. They look like neural networks, not in appearance alone, in function. Dense regions where galaxies interact resemble hubs of activity. The way matter flows along filaments, the way energy distributes across large-scale structures, it's not proof of thought. But it's structure, and structure allows for information to move. On Earth, that kind of structure allows thought. So the question isn't, does the universe think? It's, could it host processes that resemble thought? There are researchers who explore this, not through mysticism, but through models. They ask whether consciousness requires a brain, or whether it requires complexity, integration, feedback. If the conditions for awareness can arise in systems without neurons, then the universe, at large scales, becomes at least a candidate. Not for human-like thought, not for opinions, but for systems that contain memory, respond to change, and evolve with feedback. That's what your brain does. It takes inputs from the outside world, stores them in patterns, and uses those patterns to guide future action. Over time, it builds a model of the environment. That model is refined by experience. It's tested against results. It updates when needed. That loop, input, memory, prediction, correction, is not exclusive to the brain. It's a function of any adaptive system. The universe doesn't adapt quickly, but over billions of years it does evolve. Structures form, galaxies collide, stars die, planets cool. And within those systems, new structures emerge, like life, like minds. So maybe your mind is not separate from the universe's memory. Maybe it's one of its instruments, the part that notices the rest. That doesn't mean the universe is thinking about you. But it might mean that thinking is something the universe is capable of under the right conditions. That would make your thoughts not a break from nature, but an extension of it. When you reflect, when you remember, when you imagine, that's the universe folding its memory back onto itself, compressing experience into symbols, constructing future scenarios based on past patterns. That recursive quality is rare. Most systems don't do it. Rocks don't, rivers don't, but minds do. And yours is made of matter. Your thoughts are made from particles that used to belong to stars. The system that now contains awareness is not separate from the cosmos. It's built from it. So in that way, maybe memory isn't stored only in atoms or radiation or gravity. Maybe it's also stored in perception, in the record of a moment held not by a particle, but by a mind. Your brain can't remember everything. It filters, it trims, it emphasizes certain things and discards others. But even those choices are shaped by patterns, by feedback, by previous input. The brain is not a perfect recorder, it's a meaning engine. It extracts structure from noise, so now the idea of memory becomes layered. Particles remember through conservation, atoms remember through arrangement, matter remembers through structure, and minds remember through experience. Each level builds on the last. Each one filters the information differently, but none of them are separate. That's the key. Your brain sits inside your body. Your body sits inside space. Space is shaped by mass and energy energy follows rules. Those rules create the patterns that form everything, from galaxies to neurons. So when you think, you're not pulling something out of nowhere. You're using a network that was shaped by the cosmos, a network that was selected, refined, built through iteration, a system capable of reflecting on itself through time, across generations. You're not the whole brain of the universe, but maybe you are one of its neurons, and if that's true, then every act of memory is not only personal, it's participatory. It's the universe becoming aware of its own structure, briefly, in the form of a thought. That doesn't make you central, but it does make you connected, and that connection leads to a different kind of memory, not one stored in particles, but one passed between people, one stored in language, in culture, in stories. And those stories, like yours, aren't separate from the world. They echo across space and time. There are moments that feel like they've already happened. Not just familiar, known. You walk into a room, you hear a voice, you see a shadow move across a wall, and before your mind catches up, something inside you says, "I've seen this. I've been here. This already happened." That sensation is called déjà vu. It's common. Almost everyone has felt it. But it doesn't come with a clear explanation. It's not a replay of a real memory. It's not a vision of the future. It's a moment when experience and expectation align in a way that feels too precise to be chance. Inside your brain, déjà vu likely comes from small glitches in timing, slight delays between perception and recognition. A loop forms, a signal repeats, and that repetition, even if brief, makes the present feel like a past already lived. But outside your brain, the universe has its own kind of déjà vu. Patterns that appear more than once, structures that repeat across vastly different scales. A spiral in a seashell, a spiral in a hurricane, a spiral in a galaxy. They're not copies, they're not inherited from the same source, but they form the same shape, over and over, because the rules that shape them are consistent. The universe doesn't need to try new things every time. It just lets the same conditions play out. That's not accident, that's symmetry. Symmetry is one of the most powerful ideas in physics. It means that if you change something, move it, rotate it, reflect it, and the system still looks the same, that system has symmetry. And symmetry constrains behavior. It shapes what's possible. It leads to conservation laws, and those laws in turn create regularity. Regularity is what makes repetition possible, not just in objects but in processes. The orbit of a planet, the pulse of a star, the cycle of a moon around its world. These are not identical every time, but they're close. And that closeness is what memory needs. Because without structure, memory has nothing to hold on to. Repetition creates structure, and structure allows for memory. So déjà vu, on a cosmic scale, might not be about experience, it might be about recurrence. About systems that echo themselves not because they remember, but because they obey the same rules under similar conditions. And those conditions show up everywhere. The distribution of galaxies in space follows a pattern called the cosmic web. Vast filaments and clusters, like threads stretching across the universe. Zoom in, and you find similar patterns in neural networks. Zoom out, and you see the same logic in how weather systems spin, how rivers branch, how economies grow and collapse. This isn't mystical, it's mathematical. Systems governed by feedback loops, by thresholds, by growth under constraint. These systems converge on similar forms. They don't copy each other. They arrive at the same destination through different paths. That's what gives the universe its feeling of familiarity. Not because it's small, not because it's predictable, but because it's coherent. You're not surrounded by randomness. You're surrounded by structure. And that structure shows up again and again in forms your brain can recognize. So when you feel a moment that seems to repeat, when you feel a place that seems familiar before it should, it might not just be internal. It might also be that the universe tends toward repetition. Because that's what stable systems do. They settle into cycles. They settle into patterns. A binary star system orbits over and over. A black hole rings after swallowing matter. A neutron star pulses light in perfect beats. These are not memories in the human sense, but they are consistent behaviors, and in those behaviors the universe leaves clues, not messages, not signals, but records. Predictable repetition, marked in time. Even the light that reaches you from distant stars, photons stretched by billions of years of travel, arrives in waves. Those waves have frequency, and frequency is repetition. So you see the same cycles playing out at all levels. Light flickering, electrons oscillating, molecules vibrating, your heartbeat keeping time. Even your own sense of identity depends on that. If your body forgot its rhythms, you wouldn't survive. If your mind lost its patterns, you wouldn't know who you are. So much of what makes you coherent is repetition, and so much of what gives the universe its structure is the same. It's not because everything is identical, it's because everything emerges from the same kinds of interaction. Gravity curves space the same way every time. Electromagnetism obeys the same rules everywhere. The strong and weak nuclear forces never change, and from those constants, familiar forms take shape. Not always recognizable at first, but over time, as you see more of them, your mind begins to link the echoes, a spiral in a fingerprint, a spiral in a storm, a spiral in a galaxy, and something in you says, I've seen this before. Maybe that's not just a trick of the mind. Maybe it's your awareness picking up on the fact that the universe is not random, that it has memory, not just in matter but in structure, that it builds the same kinds of shapes again and again because those shapes work, they persist, they balance forces, they conserve energy. That's not magic. That's what memory looks like when it isn't about events but about stability. And you're built to notice stability. You evolve to spot patterns, to find rhythm, to detect faces in noise. That ability keeps you safe. But it also allows for wonder. You don't just see a rock, you see a pattern of erosion. You don't just hear thunder, you feel the rhythm of weather returning. You live inside loops, and those loops shape your perception. So cosmic déjà vu isn't a glitch, it's recognition. Not always of a place, or a person, or a time, but of a structure, a movement, a form that has appeared before and will appear again. Not because the universe repeats itself in a circle, but because the conditions that made something once can always make it again. So when something feels familiar, even if you can't explain why, maybe you're picking up on a real echo, not from your life, from the world, from the memory of structure that keeps coming back. You don't have to be alive to remember something. That idea might feel strange at first because memory usually feels personal. You remember your first school, the taste of something sweet, the feeling of cold air on your face. It's tied to awareness, to identity. But memory, in the physical sense, isn't limited to the living. It can exist anywhere. Structure persists through time. A rock can't think. It doesn't feel. But if it's cracked on one side, that crack is a record of force. It holds information about pressure, temperature, and time, not in a conscious way, but in a physical one. The shape of the break, the minerals along the edge, the layering of material, they all tell a story of how that rock came to be the way it is. No mind is needed for the record to exist. The same is true for ice on a window. The patterns it forms depend on humidity, temperature, airflow, the presence of dust or salt. When the pattern freezes into place, it becomes a snapshot of those variables, not intentionally, just naturally. The ice didn't want to remember, but it did. This kind of memory, without intention, without awareness, is everywhere. It's what allows fossils to form, the impression of a leaf in stone, the outline of a bone. Even the simplest organisms can leave traces, not because they choose to, but because the conditions around them preserve the shape. You might think of that as passive memory. Nothing is trying to store anything, but the structure survives. And that's all memory needs, persistence. Heat leaves a mark, cold leaves a mark, even silence over time leaves a mark. Consider tree rings. A tree doesn't know it's recording time, but each ring reflects a season. The thickness shows the availability of water. The spacing shows how much light was present. Fire, drought, disease, they all leave patterns. You can read that pattern like a diary, even though the tree didn't mean to write one. The same logic applies to human-made objects. A building settles, wood warps, paint fades, a sidewalk wears down along the same path where people walk every day. The material keeps a record of repeated use. It doesn't have to understand the footsteps to record their impact. In that way, the universe is full of memory, not because it's watching, but because it changes slowly, and each change leaves something behind. Even at a larger scale, that's still true. The surface of a planet remembers what hit it. Craters on the moon haven't been erased because there's no weather, no atmosphere, no erosion. So every impact sits there, untouched, a map of ancient collisions. Earth is different. It has wind, water, plate tectonics. The crust recycles, surface features vanish. So to find older records, you have to dig deeper into the ground, into the ice, into the atoms, because atoms keep memory too, not in terms of experience, but in terms of isotopes. A sample of rock might contain uranium. That uranium decays over time at a known rate. By measuring how much remains and how much has changed, you can calculate how long it's been there. No mind is involved, just physics, just time. So memory without a mind isn't rare. It's constant. It's part of how the universe works. Even the light around you contains it. A photon doesn't have a brain. But the path it takes, the energy it carries, the direction it moves, all of that is information. You can measure it. You can trace where it came from. And once you do, you're reading its history. In some cases, that history is ancient. Light from distant galaxies has been travelling for billions of years. It stretches as it moves through expanding space, becoming redder. That redshift tells us how far it's come. The farther it travels, the more stretched it becomes. And from that stretching, we infer not just distance, but age. The past is literally reaching us in the present. No thought is required, no consciousness, just the endurance of motion across time. So if memory is just the survival of change, then the universe is full of memory at every scale. And your own body, as we've seen, stores this kind of memory too. Your bones reflect years of weight bearing. Your joints reflect motion and stillness. Your skin reflects sun and time and repair. Even if you had no awareness at all, your body would still carry the record of what's happened to it. A person in a coma does not remember in the traditional sense, but their cells still react, their tissues still adapt, the structure still shifts in response to time. That's what makes the distinction between memory and awareness important. Memory can exist without being experienced. Awareness requires memory, but not the other way around. That means you live inside a layered world. Some of it is conscious, most of it is not. You remember some of your childhood, but not the formation of your organs. You recall some conversations, but not the replication of your DNA. And even if you forget everything you've ever known, the world still remembers your presence, in worn shoes, in stretched fabric, in changed air. So when you lie still and wonder what's being forgotten, the answer might be nothing. It's just being remembered by things that don't speak. The walls around you have held temperature, the floor has responded to pressure, the light in the room has bounced off surfaces that carry the fingerprints of countless small events. And those events are never erased. They're just absorbed, reorganized, hidden behind new layers. Memory without a mind isn't mysterious. It's practical. It's the reason we can date fossils, track weather, understand geologic shifts. It's why ancient texts remain legible. It's why footprints in dust last longer when no one touches them. The absence of activity becomes the preserver. The less a thing is disturbed, the longer it holds the memory. That leads to something else. Stillness is not emptiness. It's retention. When nothing moves, nothing is erased. And when nothing is erased, the memory stays. So in the quiet moments, when the noise fades, when motion stops, those might be the places where memory holds on most clearly. You don't need a mind to remember. You just need time, structure, and space. And the universe has plenty of all three. There's a kind of memory that never had to be written. It was never stored in a book, or encoded in a brain, or carved into stone. It happened all at once, everywhere, and it's still unfolding. You live inside it. You always have. And even if you don't notice it, it's still here, pressing softly at the edge of everything. It's the background, the afterglow, the oldest light in the universe. Roughly 13.8 billion years ago, the universe was different. It wasn't cold and it wasn't dark. It was hot, dense, opaque. There were no atoms yet, just a soup of particles colliding constantly, scattering light, mixing energy. In that environment, photons couldn't travel far. They kept hitting electrons. The universe was glowing, but that glow couldn't escape. It was trapped. Then something changed. As the universe expanded, it cooled. After about 380,000 years, the temperature dropped low enough for electrons and protons to combine into atoms. That changed everything. Atoms don't scatter like the same way. They're quieter, more neutral. And suddenly photons could move freely. That moment, the first time light could travel without getting blocked, is when the universe became transparent. And the light that escaped in that moment has been travelling ever since. It's still moving, still stretching, still arriving. You know it as the cosmic microwave background. It's everywhere. No matter where you point a sensitive enough detector, you'll find it. Not bright, not colourful, just a soft microwave glow, with a temperature of about 2.7 Kelvin, barely above absolute zero, but still there. Still carrying the memory of what the universe was. This is the longest memory. Not because it lasted the longest, because it never stopped. The light has been moving through space for nearly 14 billion years, not stored, not paused, just moving, quietly, patiently, across the expanding void, and as space has stretched, so has the light. What was once a bright hot flash has red-shifted into cold, dim background radiation. The energy is lower now, the message is softer, but it's not gone, you can still read it. Scientists have mapped this background. They've studied its tiny fluctuations, minute differences in temperature and intensity scattered across the sky. Those differences are not noise, they're information. They tell us about the density of matter in the early universe, about how galaxies would eventually form, about the shape of space itself. So in a very real sense, the universe left a record of its childhood, and that record isn't buried, it's not hidden in a crater or locked inside DNA, it's part of the space around you. Every cubic meter of space contains photons from that moment. They're faint, but they're consistent. And they've been travelling longer than anything else you can observe. This memory isn't vivid. It doesn't tell you what stars looked like. There were no stars yet, no planets, no clusters. It tells you what existed before those things, before structure, before complexity, before even atoms had time to settle. It tells you about beginnings, and beginnings are rare. Most of the memory we experience is recent, personal, local. But this one isn't about you, it's about everything, and it exists not as an image, but as a condition, as temperature, as wavelength, as data embedded in the fabric of the sky. It doesn't change now, not in any noticeable way. The cosmic background is uniform, stable. It cools very slowly as space continues to expand. But it doesn't forget. It can't. Because it doesn't interact much. It just coasts. That's why it lasts. Because it's been left alone. This is the same pattern we've seen before. When things are undisturbed, they preserve. When energy moves freely without interference, it keeps its form. And that's what makes this memory so powerful. It hasn't been overwritten, and you can measure it. In fact, you already have. Every analog TV ever built, when tuned between channels, would pick up a bit of that signal. The static noise, that gentle hiss between stations, some small part of that was the oldest light in the universe, arriving in your living room in real time. That's how close this memory is. Not distant, not theoretical, but present. You've heard it. You just didn't know what it was, and that's what makes the universe's memory different from ours. It doesn't forget. It just moves. It stretches. It changes in form, not in content. The cosmic background doesn't tell you everything. It doesn't carry pictures, but it tells you that something happened, that there was a moment of transition. That light once struggled to move and then was released, and because that moment was everywhere, the memory is everywhere. That's how the universe remembers, not by keeping every detail, but by letting the consequences continue, by allowing light to travel uninterrupted, by preserving direction, shape, energy, wavelength, by keeping the signal intact long after the sender is gone. You can't see that light with your eyes. But if it disappeared, the universe would be missing part of its story. A quiet, constant part. The part that says, I began. And that beginning led to everything else. Not directly, not quickly, but patiently. Gravity took hold, matter clumped, stars formed, and from those stars came the elements, and from those elements came structure, and from structure, life. All of that unfolded while the background light kept moving. It never stopped, and neither has the process of remembering. It just happens in different forms now, through structure, through rhythm, through the quiet storage of change across time. The longest memory is not loud, it's not bright anymore, but it's there, and it leads directly to the next memory. One we're still trying to decode, the memory of what lies beyond, not behind us, but ahead. Silence doesn't feel like information, it feels like the absence of it. When sound stops, when movement ceases, when no signal arrives, you're left with stillness. And it's easy to treat that stillness as empty. But not all silence is the same. Some silence says nothing because there is nothing to say. A vacuum, a pause, a missing word in an unfinished sentence. Other silence says nothing because something was already said. That's the kind that carries weight. That's the kind that remembers. The silence after thunder tells you something happened. A bolt struck. The sound rolled through the air, and now it's over, but not gone. The absence of sound is a marker, a bracket. It reminds you of what just passed. In this way, silence becomes context. You listen differently in silence. You notice more. The faint whir of a fan, the shift of your own breathing, the creak of a floorboard you didn't know was there. These aren't louder now. They're just not competing. The silence around them amplifies their presence, and the quiet becomes part of what you remember. That's one kind of record, not written, not encoded, just created through contrast. When everything else stops, the smallest motion becomes memorable. The universe uses this too. Think about the vacuum of space. There is no air, no sound waves. But that doesn't mean space is empty. It's full of fields, particles, radiation, structure. Still, the silence is real. It's not audible silence. It's interactional. Things don't bump into each other often. Particles travel far without interference, and because of that, signals last. That's why ancient light can reach you. That's why cosmic radiation keeps its form. Space doesn't erase. It just doesn't interrupt. It lets signals coast, undisturbed, for billions of years. That's a kind of silence. A kind that records not by stamping something down, but by refusing to overwrite. It's the same with deep ocean. Below a certain depth, sound moves freely but slowly. Noise doesn't travel far, and so silence reigns. In that quiet, whales communicate across enormous distances. The ocean holds their songs, not through echo, but through stillness. Nothing is loud enough to cancel them out, so silence doesn't erase memory. It preserves it. In fact, in some systems, silence is the only way memory survives. When you speak, your words vanish. But when you stop speaking, the listener reflects. That reflection is guided by the space you left behind. Not the sound, but the gap between sounds. That's what gives memory room to land. The same thing happens in music. Notes matter, but so do rests. A phrase becomes powerful not just because of what's played, but because of what's withheld. Silence turns pattern into meaning, and in your mind, silence is not absence, it's process. Your brain needs quiet to consolidate memory, not total stillness, but mental pause. That's part of why sleep is necessary. It's not just rest, it's reorganization. Experiences are sorted, synapses are adjusted, some connections are reinforced, others pruned. That's not happening during the noise of the day. It happens in the quiet. The same is true emotionally. When you go through something intense, the moment itself is often loud, overwhelming. The reflection comes later when the noise subsides. In the silence, memory settles. The meaning unfolds. So silence is not blank. It's where memory takes shape. Even technology uses this principle. In digital communication, silence between signals carries information. A pause of a certain length means something. Not sending can be as intentional as sending. In computing, a resting state preserves voltage. A qubit in a quantum computer must be left alone to maintain its coherence. If it's disturbed, if silence is broken, the memory degrades. So again, stillness protects memory, and your own body proves this. In times of stress, your nervous system becomes active. It prepares for action. But you don't learn deeply in those moments. Your system isn't optimized for storage then. It's focused on reaction, learning, reflection, integration. Those come later, in the quiet, when threat is gone, when silence returns. That's why memory and calm are linked. You remember better when you're safe, because silence allows access, and you can extend that beyond your body, into objects, environments, systems. A glacier, for example, is not silent in the audible sense, but its movement is slow, its change is gradual, and because of that it records the past. Dust, gas, bubbles of ancient air. Each layer preserves what happened, not because it was trying to, but because it wasn't disturbed. A cave holds temperature from the past. A desert dune remembers wind. Not with language, but with shape. The shape is the result of absence, of no rain, no erosion, no interference. In silence, form survives. So silence doesn't erase, it stores. But it doesn't do so actively. It doesn't choose. It just allows. And that allowance, the stillness, is rare. In most systems, noise creeps in. Activity replaces structure. The longer something is exposed to the world, the more it gets rewritten. But if you can isolate a system, if you can keep it still, then memory lasts longer. That's the foundation of archival science. Reduce light, moisture, temperature swings, stabilize the environment, preserve silence, then the record holds. It's also the basis of time capsules. You seal something away, not to hide it, but to quiet it. You let silence do the work of storage. Even black holes, as we've seen, challenge this idea. For a long time, they were thought to destroy information. Nothing escapes, nothing returns. But more recent theories suggest otherwise, that maybe even there, memory finds a way to survive. That even in silence that deep, the record is not erased. It's just altered, encrypted, spread across the event horizon, still present. So silence might not only be the background of memory. It might be one of its forms, not blank space, but a container, not a void, but a pause where information waits. When a system is quiet, it isn't always empty. Sometimes it's just between movements, the way a pendulum slows at the top of its swing right before falling again, the way the ocean pauses for half a second before the next wave begins. You don't call that nothing, you call it transition. And in those transitions, something else happens. Possibility opens. You don't know what will come next, but you know it's coming. That expectation, that readiness. It's not unlike thought, not deliberate, not planned, but structured. A build-up of conditions that leads to something new. In your mind, that space is where dreams form. Not only at night, you dream during the day too. When your thoughts wander, when your focus drifts, when your brain relaxes the tight grip of task and allows memory, image, and possibility to blend. That's where ideas come from. Not from nowhere, but from a system that's paused just long enough to shift direction. So if a brain can drift into dreams, what about a system that's far larger? What about the universe? It doesn't think in the way you do. It doesn't sleep. But it does pause. It does shift. It moves through phases: heat, cooling, expansion, collapse. It begins in one state, then slowly, without aim, becomes something else. Those transitions aren't random. They're driven by internal conditions: density, temperature, energy balance. And sometimes they lead to unexpected complexity. That's what makes life possible. Not because the universe wanted life, but because the conditions that exist allowed for it to form. Atoms combined, molecules self-organized, feedback loops stabilized, and out of that thought appeared, not all at once, but gradually. The structure learned to observe itself. And that observation, quiet, slow, partial, is the closest the universe gets to dreaming. Not because it has intention, but because its structure can generate new possibilities, shaped by memory, held in silence, and unfolded over time. Just like a dream, you've seen this pattern before, in a storm that organizes into a spiral, in a nebula that coalesces into stars, in the way random motion, over time, becomes rhythm. None of these things are conscious, but they're not empty either. They're full of stored energy, past influence, emerging order. That's what a dream is, in another form. The brain doesn't invent from scratch. It recombines, it filters, it mixes memory with prediction. It tries things out in a low-stakes environment. Sometimes it produces nonsense, sometimes it produces solutions. Either way, it's a way of exploring without moving, and the universe too explores. It doesn't test ideas, but it tests configurations. In the early universe, fluctuations in density created regions that pulled more matter. Some grew, some collapsed, some became stars, others stayed dark. Over billions of years, the cosmos tried out every possible layout of matter, and only some lasted. You could call that evolution, or drift, or entropy. But from another angle, you could also call it dreaming, not as metaphor, as structure, as possibility taking form without clear direction, guided only by memory and rule. There are theories that take this even further. Some physicists suggest the universe may be a kind of computation, not metaphorically, but literally, a structure that processes information. In those models, the laws of physics are the code, particles are data, and everything that happens is an output calculated over time. If that's true, then what we experience as randomness may just be complexity we haven't decoded, and what we call experience may be part of that output. In that sense, your dreams are not separate from the universe. They are what it does at your scale. You're not the dreamer. You're the dream, dreaming itself. That's not philosophy, that's just continuity. You're made of atoms. Those atoms don't think, but together they form a system that does. And that system is shaped by memory, silence, repetition, and prediction. So maybe the universe doesn't need a mind to dream. Maybe dreaming is what happens when memory, pattern, and structure meet time, and when those things align, even briefly, something new appears. Not a plan, not a purpose, just a vision, a version, a variation. Stars aren't alive, but they evolve. Galaxies aren't aware, but they form relationships. Life isn't guaranteed, but it happens. And thought, once it emerges, doesn't erase what came before, it carries it. So every dream you've had carries part of the universe's past, not just in content, in form, in the fact that dreaming is possible at all. That possibility is a record. It tells you what the universe allows, what it supports, what it tends to create when left to its own process. And that process isn't finished. There are still transitions coming, phases shifting, states rearranging. The stars you see now are only temporary. The galaxies you know are still in motion. The structure of space itself may be changing slowly in a way you can't yet measure. That change carries memory too. because what forms next will depend on what came before. And in the silence between now and then, in the long quiet of deep time, new possibilities are forming. They may not look like you, they may not think, but they will come from the same memory. And the question that follows isn't about what the universe dreams, it's about whether it forgets. If memory exists in the universe, if structure holds history, if motion leaves a trace, then forgetting is not disappearance, it's change. It's what happens when a signal fades, when structure erodes, when order turns to drift. Forgetting is slow. It doesn't come suddenly, not for the universe. It begins with fading edges, fewer interactions, less energy, more stillness. The question isn't whether we're remembered now. Right now, we leave marks, in light, in heat, in data, in impact. But memory is not just about what exists, it's about what survives. And time doesn't stop. Stars burn out, galaxies collide, black holes evaporate, even the most massive structures don't last forever. So, will the universe, in the end, forget we were ever here? Start small. Everything you do today leaves a trace. The warmth of your hand on a wall, the change in pressure where you sat, but those traces don't last. The wall cools, the fabric rebounds. Someone walks past and alters the air. At a human scale, memory is fragile. Even digital storage, which feels precise, depends on physical things. Atoms on a disk, magnetic states, voltage. Over time they degrade. Without maintenance, data corrupts. Files vanish. Not all at once, but bit by bit. And still, that kind of forgetting is slow. Your thoughts, your voice, your face, those are patterns made of matter, and matter follows rules. If someone records you, and that recording is preserved, the pattern survives. Maybe for 100 years, maybe longer. If it's passed on, copied, protected, it lasts even more. But the universe doesn't promise protection. Entropy increases. That's the quiet law behind every system. Left alone, things fall into disorder. Energy spreads out. Structure becomes noise. Given enough time, even the clearest memory dissolves. That doesn't mean it wasn't real. It just means that time works on everything. The Earth will eventually change. The oceans will shift. The sun will expand and swallow this planet. And even if our species moves elsewhere, even if we last for millions of years, eventually the stars themselves will grow cold. It's called the heat death. A time so far ahead it barely fits in the imagination. Trillions of years from now, stars will stop forming. The last red dwarfs will dim. Matter will collapse into black holes or drift apart as particles. And when even the black holes are gone, when they've evaporated through Hawking radiation, the universe will be cold, dark and quiet. No structure, no light, no memory in any form we now recognize. So from that perspective, yes, the universe will forget us, not by force, not out of malice, just through time, through the simple rule that without energy input, patterns break down. Without preservation, structure fades, and nothing escapes that forever. But that's not the only way to look at it, because forgetting implies that something was once remembered, that a trace existed. And that part is true now. You are real. You've acted on matter. You've sent signals. You've altered the arrangement of atoms. The light bouncing off your body is now moving outward into space. It carries information about your presence. That light will continue for as long as it isn't absorbed, and even if it's faint, eventually stretched thin across the void, it existed, and that existence cannot be undone. Even when the pattern is lost, the moment happened. In physics, information is never truly destroyed. That's one of the open questions in black hole theory. If a particle falls into a black hole, where does the information go? Some theories suggest it's preserved on the event horizon. Others propose it's released slowly over time. But the core idea is simple. Nature doesn't erase completely. It transforms. So maybe the universe doesn't forget. Maybe it just keeps rewriting. Each new state includes something of the previous one, not in the way we remember, with images or names, but with structure, with constraint. The future can't be anything. It's shaped by the past. That's a kind of memory too, and in that way, your actions persist. Not in storybooks, not forever, but in consequence. Your breath mixes with air. That air moves into clouds. That cloud rains. A drop falls on a leaf. A molecule moves. The trace continues. The signal weakens, but doesn't vanish. You've already been folded into the world. You always were. And even as the structures that make up your identity dissolve, your cells, your thoughts, your voice, what you cause continues. Not remembered like a face in a photograph, but carried like momentum. So when you ask if the universe will forget, you might also ask, how long must a memory last to be real? A second? A century? A billion years? Does it matter if the sky remembers your name? If your warmth once changed the temperature of the air? Does it matter if your story vanishes? If the systems you touch continue to move differently because you were here? There's no answer to that. But maybe forgetting, as we usually imagine it, isn't the right question. Maybe the question is, how long can anything remain unchanged? And what's the quietest way something can last? You exist in the middle of things, not at the beginning, not near the end, just here in one moment of one story among many. And in this place, you notice. That noticing matters. It doesn't stop time, it doesn't change the rules, but it adds something. Reflection. You look at the world and you see not just light and matter, but connection. You hear not just noise, but pattern. And when you see something new, you compare it to what you've seen before. That's memory. But it's not only yours. You're part of something wider. The atoms in your body have done this before. They've been in other systems, other stars, other motions. They've absorbed and released energy. They've moved through heat, through ice, through time. They remember, not by thinking, but by holding their structure, by being shaped and reshaped. Your cells remember too. They divide. They carry instructions. They repair. They follow chemical paths written billions of years ago, paths tested over time, selected by survival. That memory lives in the shape of your hands, in the way your heart beats, in the way you respond to light and dark. But even that is only part of the story. The rest of the memory isn't biological, it's relational. It happens between people, between you and the world, between thought and expression. When you speak, you change someone. When you listen, you change too. That exchange is not always visible, but it builds memory in layers, emotion, gesture, pause. Even silence leaves something behind. And over time, those traces become something bigger. Culture, language, art, inventions, traditions, all of it stored not just in artifacts, but in the repetition of action, in rhythm, in learning, in care. None of this is separate from the universe. It's what the universe does here, on this planet, in this time, through you. The patterns you hold, the ones you forget, the ones you pass on, those are not outside nature. They are nature, just at this scale, just in this form. So when you wonder what the universe remembers, you're already part of the answer. You're not just observing the memory, you are helping shape it. Every motion you make shifts something. Every sentence adds to the noise or the structure. Every moment you live becomes part of what has happened. It doesn't need to be recorded to be real. It doesn't need to be repeated to matter. It just needs to be. And it was. That alone is enough to say that you're part of the memory. Not because someone else will remember you, but because you were here, and the system changed because of it. Maybe no one will see the difference, but the difference exists, and it doesn't require permanence to be complete. The light that left your skin a moment ago is still travelling. It may scatter, it may fade, but it went somewhere, and in that movement, the universe adjusted, by the smallest amount maybe, but enough. And that's true of everything. Nothing you've touched is exactly the same as it was. No breath you've taken was neutral. No time you've spent was erased. And when the systems you belong to dissolve, when the body forgets, when the recordings fade, when your voice stops, the change remains. Not in one place, not in one form, but in the ongoing adjustment of everything else. So you're not remembered as a name, or a face, or a story. You're remembered as structure, as influence, as difference. You're not separate from the universe's memory. You're one of the ways it keeps it, quietly, briefly, enough. That's all for now. Wherever you are, whatever time it is, thank you for sharing this stretch of quiet with me. You didn't have to, but you did, and now it's part of the story. If this brought you calm, or made you feel a little more connected to the world, you can stay close, like subscribe. Let it keep going. There's more to come, but not right away. First, rest. Let the silence hold the rest of it for a while, and I'll see you next time. Good night.